Hey everybody, I'm Brian Contos. I'm the Chief Security Officer with Phosphorus Cybersecurity. Today's presentation is Cameras, CACs, and Clocks. Enterprise IoT Security Sucks. This is a story of 2 million interrogated IoT devices. This slide I just said yikes. I didn't really know what else to call it. So I went over to Shodan, and I think most of you are familiar with that, the Shodan search engine, to see which devices are internet accessible, if you will. And I just typed in a couple terms that you would think of for IoT devices. I've got camera, voice over IP, printer, and UPS. So not very scientific, just typed them in. But what we find here is almost 5 million cameras, over 250,000 voice over IP phones, 83,000 plus printers, and almost 14,000 UPS systems, which, oh my gosh. And the thing about UPS systems, I won't tell you, but you can Google this. The password is almost never changed, and it's a very, very simple password on these. It's actually the same credential for username and password on these devices. I don't know why they would be exposed on the internet. But IoT devices don't need to be exposed to the internet for these attacks to happen, but certainly the fact that many of them are increase the likelihood. Also, we're seeing a lot of nation states now paying attention to IoT and investing quite a bit. And this is globally. So Russia has this tool called Frontin, which was developed for them by some contractors, specifically for the Russian FSB. And this was an IoT hacking tool designed to find, compromise, and compromise IoT devices, install command and control software, and do whatever they wanted from that point, or also use that as a jumping off point to get in deeper into organizations. Interestingly, a hacking group called Digital Revolution got their hands on Frontin and released the code, so you can get it from torrents and all the places that you like to get your hacking tools from. Another interesting case is there have been IoT devices that have been banned. Actually, the U.S. House of Representatives has passed bills that prohibit federal agencies and contractors from actually using certain IoT devices. So, I mean, they're that well known to have that level of vulnerability that they're just not allowed. In our research, what we've actually discovered, and these numbers actually blew me away before I really started getting involved with these organizations, there's about 3 to 5 IoT devices per employee. So this is the craziest looking possible chart to show that. But if we just look at 10,000 employees, for example, 10,000 employees, you probably have somewhere between 30,000 and 50,000 IoT devices. That's a lot of devices. And it's way more devices than you could possibly manually manage in terms of taking care of the firmware and taking care of the passwords and turning off unneeded services. It's just completely untenable. You need automated tools. You need a centralized process to handle that. But it just kind of shows you the breadth and depth of this problem. Now, if you look at law firms, for example, they'll have a little bit less. You look at retailers, they'll actually have quite a bit more. So it kind of depends on industry, but on average, take a look at your organization. There's probably about 3 to 5 IoT devices per employee. Right? And we'll get into some of the IoT devices that we see quite a bit of in the worst offenders, and you'll start going, oh, okay, yeah, if I start including these things, I can completely see how that goes. And just like with the stock exchange, we were talking about those cesium clocks. When we go into organizations to do a proof of value, and we say, hey, how many devices do you think you have, IoT devices? And they'll say, I don't know, I have X. Almost 100% of the time, their numbers are off by about 40 to 60%. So again, they just didn't know about half of their devices in their environment. So we talked about printers a little bit before. Printers are really a special case because everyone's got them and everyone's got a lot of them. We work with some folks in the hospitality industry, for example, where they have tens and tens of thousands of printers, just printers, different models and brands and versions and things like that, but they have lots of printers. Now, the thing about printers is most sort of enterprise level printers have about a 20 gig hard drive. It's not huge, it's not small, but it's a pretty good size hard drive. And what had happened is some attackers had gotten access to these printers, which, by the way, most of these run common operating systems like Linux or Android and things of this nature. In fact, across all IoT, a flavor of Linux or a flavor of Android is by far the most common thing that you'll find. And by the way, they have a lot of the same capabilities, services. In the case of printers, however, they're far more promiscuous in running so many different protocols. They've got every protocol imaginable because they want to be easy to use. They want people to be able to connect to them and use them. It's the point of the printer. So from that perspective, it makes great sense. But attackers know that, And because they know that, they take advantage of the fact that those printers are so promiscuous and there are so many ways to connect with them. So in this particular case, some attackers had gained access to the printer. They had uploaded some of their tools. And this was only to a few dozen printers at the time, but it did expand greatly to hundreds later on. And they used those to go out searching for other critical devices on the network, IT devices primarily. And from them, they were extracting data. This was all about intellectual property theft. They were extracting the data, and then they were storing it on those 20 gig hard drives. And I'll get to what happens next. Well, a lot of this activity, because it was all being controlled through various remote connectivity controls and C2 and things of that nature, it created logs. And those logs were showing up in Splunk. And they were anomalous. And they said, hey, we've got a lot of printers that seem to be pretty chatty, and we're not really sure why. And then what they were seeing was data exfiltration. And these printers, they were being set up to exfil data over ICMP. Why? Because everybody allows ICMP out. And even if it's shut off, network ops turns it back on to do some testing. They forget to turn it off. Just a really easy way to exfiltrate data. You have to make the packets pretty small. Takes a little bit longer, but it usually goes under the radar. So they were using these printers to grab IT-sensitive data, compressing it up, exfiltrating out over ICMP, which eventually caused some alarms to go off. And what they found was when they started looking at these printers, and they say, God, it's not just one or two. We have several dozen now, more than 100 now. They're infected. It was just the firmware. They're running really old firmware. Some of these devices hadn't been updated in up to 10 years. Most of them hadn't been upgraded for about 4 or 5 years at least. So they were just sitting there vulnerable. They were doing their job. They were working fine as printers. And usually most people don't pay attention to a printer until it stops, well, printing. So the fact that they were running all this old firmware just made them a big target with a big juicy hard drive and an easy way to exfiltrate that data out. Now, talking about firmware, about 26% of the devices we counter have end-of-life firmware, meaning that there's just nothing we can do with that firmware. It's completely end-of-life. If you're running it, you have to get on a newer version of it. Of the remaining 74%, the average age was 6 years old. Think about your smartphone. It probably wouldn't work if you hadn't updated things in 6 years, and I'm almost certain it wouldn't work. But now you're talking about your enterprise devices. Again, all of your key systems, especially the systems that manage other systems. And that's really a scary stat, because if we think about it again, there's not a lot of difference between an IT device and an IoT device in terms of capability, network access, and the type of negative ramifications it can cause upon your environment. And again, with IoT, you can even cause physical harm. So if I went and told you 26% of your IT devices were our end-of-life firmware, you'd jump off this video right now and you'd go fix those. That's how serious this is. So when we start digging into the actual statistics around the vulnerabilities, what we found, and this is probably one of the most frightening statistics so far, the CVEs scores, so scores of 1 to 10, 10 being the most grievous, 50% of the devices have a score of an 8. An additional 18% have scores of 9 or 10. These are high to critical level vulnerabilities. These are the type of vulnerabilities where you don't need local access. You can do remote exploitation. They're very severe. The great majority of the vulnerabilities discovered on these devices were 8s, 9s, and 10s. That's a scary thought. Again, this is one of those things where if these were your IT devices, you'd be like, oh my God, what can I do? But because IoT devices historically have been so hard to first of all, just discover, then manage the passwords, address the vulnerabilities in the patching and the firmware, manage services, etc., nothing's been done. Let's dive into the biggest IoT offenders. And these are the devices where we see sort of the most grievous issues across the board. Now, we see a lot of other devices that I'm not listing here, but we just had to sort of condense it into the ones that keep on ringing out as being problematic. Again, the pictures that you see here are not the actual brands. I'm not going to call anybody out here. That's not the focus here. But KVM switches. Again, most of you are probably familiar with KVM switches. But a KVM switch, you stick it in a rack, you connect it to multiple computers, and it lets you control keyboard and mouse and video, and sometimes you can cycle power as well. We come across a lot of these devices that are running like Linux Ubuntu version 10. Well, that's from 2010, right? I think the latest version now is 21 point something. It's a little bit past 21.1. So it's running old stuff, and because of that, it doesn't just have a few, but they have hundreds hundreds of vulnerabilities. Now think about this. I've spent a lot of money on my endpoint security and application security, identity this and network security that, and now I've got this KVM switch that can backdoor into all these devices, running a version of Linux that's more than a decade old, that if I'm an attacker and I can compromise that, I can do a lot of malicious things to those devices that are connected. I can probably power them off. I can change configurations. I can, modify stuff, steal stuff, whatever I wanted to do. So that's a huge backdoor. And that's one of the reasons that a lot of nation states, and we talked about Russia earlier, are building these tools, because why bang your head through the firewall and the IPS and the encryption that and application security and endpoint security when I can just go around that back door? Again, like 1995 with that US robotics modem plugged into the back of that Windows NT 351 server in the back of the data center that everybody forgot about, right? So KVM switches, one of the biggest offenders that we see out there. Another big one, lights out management controls. So if you look at the back of this server, we see a couple Ethernet ports on the right and something that looks like an Ethernet port where that arrow is. Well, that's not an Ethernet port. That's a lights out management port, right? That's what you're going to use for management of these devices. Well, the thing about these is there's a few different flavors. There's HP has ILO, Dell has iDRAC, Supermicro has IPMI. So there's a few different flavors. Those are the main ones. They're just little Linux servers. In fact, there's malware specifically designed to target those little Linux servers for lights out management systems. And again, like the KVM switches, but a little bit more powerful actually, these lights out management controls bypass all that other security that you've put on top of that server. So you could have $10 million of endpoint security on top of this thing. But if that interface isn't secure, if it's running a default password, for example, or a weak password, or it has a vulnerability in it that can be exploited because that version of Linux or VX work that's running on that has not been updated in the last 10 years, that's a problem. Because now as an attacker, the things I can do for that is I can shut the system down, I can change the network settings, I can run a shell. Some of these guys I can pop open a virtual terminal as well. I can upload software or malware. I can do all the bad stuff that an attacker would want to do. And again, most of your critical servers are going to have these devices. And some people say, oh, well, I didn't even know that thing was there. And that's the problem, again, because there's no good inventory for discovery for a lot of these products. Server cabinets and racks. This is another one that people tend to go, oh, those do have a lot of IoT devices. They sure do. UPS systems, which are notorious for having the vendor's default password, which takes about 5 seconds to find if you Google it. Cooling systems, cable management, tamper resistance sensors, and all sorts of other things, depending on how fancy that rack happens to be. And they're really cool and they're really capable. They're almost always running the oldest firmware known to man. And the reason for that, I think, the primary reason is if I want to upload all the firmware on my rack, including my UPS system and everything else, I need to reboot that system in most cases, which means all those devices that are relying on that, switching gear, routing gear, computer systems, etc., they're going to have to be rebooted as well. So there has to be a change window. And when people schedule change windows, they don't always think about IoT devices, unfortunately, which causes this problem. So these devices are frequently vulnerable. And a lot of these are also tied to KVM switches that we talked about earlier, exposing you to a lot of problems. Physical access controllers. Here's another case where you probably have oodles and oodles of these throughout your environment, whether it's biometrics or a PIN or a scan card or a CAC system, whatever the solution might be. Again, these are Linux devices that are running on the network. And in one particular case, we're working with a customer, and they had the system deployed. It was all default passwords, but if those passwords were not default, and it's crazy to find the default passwords on door locks. It's crazy to think, but you always find it. They had 3 critical CVEs. So had that default password not been there, it would have been easy enough to get through one of the critical one of the 3. You could pick the one that you like most to get into that system. And we're sitting with the CISO and their team, and we're actually able to show them with a click of a button, we could have locked or unlocked all 6,400 door lock systems that they had throughout this financial services company. And again, the IoT devices can have that impact on the physical world. Printers. We talked a little bit about printers before. they're certainly one of the most commonly attacked devices, especially from nation states, but cyber criminals like them too. If any of you were at Black Hat back in 2019 in Vegas, there was some research that was released where they found critical level vulnerabilities. Again, these are level 10 vulnerabilities on over 10,000 different printer types and brands. And there's just so many different types of printers out there, but that's pretty incredible. Over 10,000 devices had critical level vulnerabilities. And again, they're highly promiscuous. They're running a lot of services. They've got wired and wireless connections. They probably have Bluetooth. They might be running other protocols as well. You can manage it via HTTPS or SSH. Some of you can telnet into. They're just very, very open, and that's taking advantage. And again, because a lot of them have that big storage drive, it's great to use them to attack IT devices and exfiltrate your data out the way we talked about it before. But again, it's one of the biggest targets for state-sponsored hackers. I would say it's probably in the top 3. Next one, voice over IP phones and video conferencing systems. Like printers, organizations have a ton of voice over IP systems. And even when people weren't at the office, there's still so many active IoT systems that we actually saw an uptick in the number of attacks on IoT devices. But now, I guess they're calling it the Great Return. Here in Silicon Valley, we see, the likes of Apple and Facebook and Google. People are all going back to work again. Traffic's increasing because of that, which is usually a pretty good sign. Probably an IoT device could detect that. But there's a lot of these voice over IP phones, and they're usually running a flavor of Android. What we find with a lot of these devices is they've got undocumented SSH administration capabilities running on them with default credentials again. And a lot of this goes back to what we were talking about before with the manufacturers of some of these devices aren't necessarily software development houses. They're more, they manufacture things, sometimes like farm equipment and things of that nature. So they have a small crew. They're not putting a lot of time and effort into testing, certainly not looking at security. And if they are, it's very little. And because of that, they're saying, well, I'm just going to white label that. I'm going to use that library from that group. And they might not even know they have that undocumented SSH with default credentials, right? And it just got rolled out that way because they hadn't done that level of testing. So that's a pretty scary thing. With this one organization, I guess you can call this a beacon of hope, but maybe it's kind of sad. They had 31,000 phones. Only 700 had a critical level CVE. As we know, it really only takes one. So these, again, are an example of something that there's just so many. They're so voluminous, 31,000 phone systems. If you wanted to upgrade the firmware or rotate the passwords every 90 days that you use for managing those or whatever steps, it would be impossible to try to do these things manually. And then the last group I wanted to cover were our security cameras. These suck the most. There's so many of them, and there's so many problems. Again, some of these cameras ship directly from their manufacturers with the malware already installed. So you skip the middleman. You just go straight to being infected and having your device controlled. These cameras have been known to actually turn on when they're supposed to be off. They're known to record audio when they're supposed to be on mute. And they also take these streams and they can pipe them back to various countries. So that's a problem right there. And again, a lot of these devices have been banned. But cameras are devices that, if they're compromised, they can certainly be used for spying. We mentioned some of the attacks that are very common in IT and IoT and how they're the same, from ransomware to data theft, DDoS, command and control, malware distribution, things of that nature. One case we were working with a customer, I think they had something like 9,000 or 9,500, a lot. They had a lot of video cameras, and they had been cryptojacked. Which most of you probably know that means I want to take this device and I want to use it to mine crypto. So they had all these cameras that were doing crypto mining. And the way they detected it, I'd love to say it was some cool SIM tool or alerted this. It was their power bill. Their power bill was really, really high, and they didn't know why. If you've ever looked at organizations that do crypto mining, it's pretty energy intensive. So that's how they found it. These guys are usually running Linux, usually some form of like BusyBox, which is a common piece that's on there. And the thing that's interesting about video cameras is a lot of the older ones are designed so I have 10,000 cameras, but they all have to have the exact same password that's talking to the management console, like something like you see here in the middle. Which is an architectural flaw. I mean, you could set it up, and there's some newer ones where you have the streaming password is the same, but the management password is different. So it has two different passwords because of that issue. So when you're talking about password management on these things, you have to keep in mind that, hey, if you are going to change the password and use something complicated, now I have to do it for all 10,000 devices, and it has to be the same thing. It has to be a group password. Again, from a security perspective, not a great design, but sometimes you have to work within the limitations of those devices as well. So again, virtually every organization has hundreds, if not thousands, or even tens of thousands of these types of devices. There's often finger pointing when it comes to cameras. Well, I thought facilities took care of that. No, I thought IT did. No, I think it was supposed to be security. And it's kind of like Spider-Man, right? They're all pointing at each other. It's just very commonly targeted, and they tend to be very easy to take advantage of. And on the consumer side, again, we're not focusing too much on the consumer side here, but one of the most popular cameras on Amazon last year, the most popular camera, highest rated, approved this and that, shipped with malware already installed on it. To summarize, IoT devices, they're virtually always vulnerable. I wish there was another way to say that. It just sucks, hence the title of the presentation. Historically, it was really hard to just find these devices. Just say, I don't even know what I have. I know I got a bunch of cameras and some door locks, I think, and I don't know, lights out management. I hadn't even thought of that. But just finding them, that's a problem. Then the next step, of course, is once they're found, remediating the risks, which is the bigger part of the equation, right? I just don't want to find it. I want to fix it. And then I want to keep it fixed, right? So that's really important. And now there's solutions to help with this, right? Enterprise IoT security platforms, somewhat of a newer concept in this world. And I put a couple versions down here. Of course, this is something that Phosphorus does, but we're not the only people that play in IoT security. You can take a look at some of these other vendors. Everybody has a little bit of a different approach to this. Some a little bit more legacy, some a little bit more modern. But now these tools can help you discovering the device and what vulnerabilities are on my device, updating my firmware, managing those credentials and those certificates and hardening those devices. And then what's really critical is integrating with all my other IT security tools for logging, for SOAR capability, for ticketing systems. And then being able to pull all that together with a reporting capability that makes this easy for me to manage at scale. And if you're able to do this, not only are you able to sort of discover your IoT environment and lock it down, but you're able to do it at scale with these automated tools and make these devices secure. You're just not hiding them off in a VLAN. You're just not closing your eyes and hoping nothing bad's going to happen. And you're greatly reducing the risk on your organization with something that's very easy to do. In most cases, running discovery from these enterprise IoT security platforms is like running a vulnerability scan, right? The firmware is just kept up there. You don't have to go hunt for the firmware yourself. The integration, API integration with the PAM tools is already there. It just works and it just fits. So something you probably want to check out if you're trying to address your IoT security. So again, my name is Brian Contos. I'm the Chief Security Officer with Phosphorus Cybersecurity, and thanks so much for your time.